Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to talk about atomic structure. First up, let's talk about atoms. So, what are they? Atoms are the building blocks of matter. Essentially, they are the smallest particles of an element that still have that element's properties. There are components of atoms like electrons, protons, and neutrons that are smaller than the atom itself. However, they don't have characteristics specific to their element. They're much more general. While we had determined the existence of atoms well beforehand, atoms weren't seen until 1981, after scanning tunneling microscopes were created, otherwise known as electron microscopes. Since scientists couldn't see what atoms looked like, they used models based on atomic theories and all known experimental evidence that they had access to at the time. Prior to actually seeing atoms, scientists were aware that all atoms are very small. That being said, atoms of different elements vary in size, which means that they're all different sizes depending on the element. Anyways, atoms themselves have three main components: protons, neutrons, and electrons. The nucleus is a small, dense region at the center of the atom which contains positive protons and neutral neutrons. Since the protons are positive and the neutrons are neutral, this means that the overall charge of the nucleus is a positive charge. This is also the location that contains almost all of the atom's mass. So how do the protons and neutrons stay together within the nucleus? There are what's called strong nuclear forces which hold the protons and neutrons all within the nucleus. These strong nuclear forces are stronger than the electric force of repulsion between protons. You can think of it like an arm wrestling match. The nuclear force arm is stronger than the force of the repulsion arm, so it always wins and holds down the other arm. Now that we have introduced the three main components of an atom and talked about where two of those three are located, let's look at the components more in depth. Now, as I mentioned before, a proton is one of three main particles that makes up an atom. These protons have a positive electrical charge, +1. They have a relative mass of 1 atomic unit, which is represented with AMU. The second main particle of an atom is the neutron. Again, these are neutral in charge. Similar to protons, neutrons also have a relative mass of 1 atomic unit, or AMU. Now, the third and final main component of an atom is the electron. And these are smaller than both protons or neutrons and have a negative charge, or a negative electrical charge, I should say, of -1. Now, due to this negative charge, electrons are attracted to the nucleus, which has an overall positive charge. Remember, protons are positive, neutrons are neutral, so overall that nucleus is positive. Now, this force of attraction between the negative electrons and the positive protons is what keeps electrons moving around the nucleus in what are known as orbitals. So, what are orbitals? Essentially, they are the regions where an electron is most likely to be found. Now, amongst these orbitals, there are different energy levels. And these energy levels are fixed distances from the nucleus to where the electrons are located. The lower the energy level, the less energy that electron has. The farther you get from the nucleus, the higher the energy level of the electron. This means that the farther away from the nucleus the electron is, the more energy it has. Now, electrons themselves get added to the lowest energy level first, or the closest to the nucleus, until it has the maximum number of electrons possible. The number of electrons at a given energy level depends on its number of orbitals, and there are 2 electrons per orbital maximum. Every atom has an outermost energy level, and the electrons that are present here are known as valence electrons. These valence electrons determine many properties of an atom, including how reactive it is. Anyway, on to another topic. Let's look at different atomic forces. So we've already touched on a couple of them, like repulsion and strong nuclear forces, but let's take a few minutes for a deeper dive. First up, let's talk about electromagnetic force. Now, as the name suggests, this is the attraction between negative electrons and positive protons, or repulsion between positive protons and positive protons. The electromagnetic force between protons and electrons is an attractive force, which keeps electrons in the area surrounding the nucleus. The electromagnetic force between protons and protons, however, is a repulsive force. But like we talked about, that is overcome by the strong nuclear forces between protons and neutrons. Now, I keep using the term nuclear force, so what exactly am I referring to? It's just the attraction between fundamental particles. The strong nuclear forces keep protons and neutrons held together in the nucleus, while weak nuclear forces change subatomic particles from one type to another. That means that protons can be converted to neutrons, which changes atoms of one element to atoms of a different element, and this is done by changing the atomic number. But what is the atomic number? This is the number of protons in an atom, which is unique to each element. Typically, the number of protons in an atom is equal to the number of electrons in an atom. However, there are times when this is not always the case, but we're not going to get into that right now. Different from the atomic number, atoms also have an atomic mass number. This is the atom's mass in atomic mass units, which again is represented by the abbreviation AMU. The atomic mass number is equal to the total number of protons and neutrons in the atom. Now, elements can sometimes vary in their mass number, and these are known as isotopes. Another way to put this is that different isotopes have different mass numbers, and this is due to there being a different number of neutrons present. Now, we're going to touch more on that in a minute or two, but first, let's talk about ions. So what are they? Ions are atoms that have lost or gained electrons. When an atom loses electrons, it becomes a positively charged ion, and these are known as cations. A good way to remember that is that cations are positive, like a cat and a paw. When an atom gains an electron, it becomes a negatively charged ion, which is the opposite, and these are known as anions. Now, these tend to be very reactive, and they get deflected by a magnetic field. Now, I know that I mentioned ions form when atoms gain or lose electrons, but there is a specific term for it, which is ionization. By definition, ionization is the process in which an atom becomes an ion. Now, this may occur from high levels of radiation or when atoms transfer electrons to other atoms, like in chemical reactions. And now that we talked about ions, let's get back to isotopes. As I mentioned before, an isotope is atoms of the same element that differ in their number of neutrons. Different isotopes of the same element typically have the same physical and chemical properties, which is due to isotopes having the same number of protons and electrons. Remember, in isotopes, it's the number of neutrons that differ. Isotopes can play an important role in naming atoms. Let's look at hydrogen specifically. When hydrogen atoms have no neutron, which is the normal state of hydrogen, it is named hydrogen. When a hydrogen atom has one neutron, it is known as deuterium, and when a hydrogen atom has two neutrons, it is known as tritium. Now, hydrogen is a little bit of a special case. Most other elements are named with their mass number instead of totally new names like hydrogen. An example of this can be when a carbon atom with a mass number of 14 is named carbon-14. Which, fun fact, carbon-14 is often used for carbon dating, which we'll talk about in one of our episodes regarding fossils. Now, even though atoms can have different isotopes, atoms do need a certain ratio of neutrons to protons in order to be stable. When an isotope has too many or too few neutrons, it results in an unstable atom, aka it's radioactive. When an element's radioactive, it decays to a more stable form. Now, this decay, or shooting off of particles, is what makes it radioactive. These radioactive isotopes get a special name, aka radioisotopes, which is just a fancy way of saying that it is a radioactive isotope of whatever version or whatever element that we're discussing. And that brings us to the end of today's lesson. Until next time.